So white matter, fast or slow? Fast. Unmyelinated or myelinated? Myelinated. It contains both, but when you think white matter, you're thinking fast, sending the signal fast, and I'm sending it through axons versus gray matter. Yes, you might have unmyelinated axons, but for this class, remember cell bodies for processing information. A lot of times, the gray horns are going to have processing information with cell bodies, especially your nuclei, and the color that you see on image is going to be gray for nuclei and white for tracks. So posterior white columns, anytime you see a column, you think tracks, right? Posterior, anterior, in this case, let's not cover it this way. We have other things that I'll test you on. So tracks, or groups of axons, also known as fasciculi. Ascending is for SAD, right? Descending is for MEV. So ascending, sensory, afferent, dorsal is also ascending tracks. Takes sensory information up to the brain. MEV, descending, motor, efferent, ventral. Descending tracks take information from the brain down to the spinal cord. So the examples that I told you to remember were, if it starts in spinal, let's say spinal, and it ends in the thalamus, thalamic, that's not the only one, but if I start in spinal thalamic, this is an ascending track, it's SAD, so it's a sensory track. What if it was spinal cerebellar? Yeah, spinal cerebellar is sending information from the spine up to the cerebellum, which is the balance, coordination, and unconscious proprioception. But what if I have something that ends in spine? So let's say cerebrospinal. If it ends in spine, then it's a descending track and it's motor, efferent, or typically ventral. Not always, remember there's always exceptions. Instead of cerebral, let's say that it comes from a red nucleus, so they call it rubrospinal. There's so many more. There's tectospinal, there's nigrospinal, there's reticulospinal. There's a ton that we can remember, but if you notice, the ending is always the same. The pattern is consistent. These are all motor tracks. Whereas if it starts in spinal, ends in cerebellar at some point, or even starts in the face. So you can say something like facial cerebellar, or facial thalamic, and it's the same thing. The idea is that it's ending somewhere in the brain and starting somewhere below. So the face is below the brain. So that one would be an example too. So these are still sensory tracks. And over again, whenever I look at this cross section, these guys look like roots extending off of the trunk of a tree. So this is on the front, it's ventral root. This is on the back, it's dorsal root. This is the dorsal root ganglia. So this whole thing on the back side is for sensory, afferent, and dorsal. This whole thing on the front side is motor, efferent, ventral. And when these two combine together, they make spinal nerves. The thing about spinal nerves is this.